Okay, so we're going to go ahead and get started. So this is Freshwater Species and Ecology. As I mentioned before, this will be lecture heavy. So let's start with a few ecological terms. I want to kind of get a good ecological basis before we go into both this lecture and then our next few lectures. This is community naturalist, right? So we're going to talk about ecology on a community level. So to define ecology first, it's a multi-level study of the relationships between organisms and their environments. And what constitutes an environment can depend on scale. So a biosphere is going to be the largest scale that we have in ecology. It's the globe. And then the smallest scale will be an individual. So that's the individual organism and how it relates to its environment and other organisms. In between that, we have region, landscape, ecosystem, community, interactions, and populations. Community is what we're going to be focused on, and that is defined as all the organisms within a certain place at a certain time. So for community, we're looking at particularly the richness, the abundance, and diversity of species. So when it comes to species richness, we look at the number of species in a community, and that's the number of different species. So let's say outside, we have starlings, we have crows, we have robins, and we have pigeons. So that would be 4 species there. That would be species richness would be 4. Species abundance is the relative abundance of that species compared to the total. So when we have pigeons, we have a lot of pigeons. I would say we have probably more pigeons than robins in this particular community outside. So comparative, there would be more pigeon abundance than robin abundance. Most species are going to be moderately abundant. Fewer species are going to be rare, and even fewer are going to be highly abundant. When a species is highly abundant, that's usually when we see invasive species. So those organisms that are really, really good at being the most competitive organism in a community. So when we go back to that past lecture about the invasive mussels in the Great Lakes and how those invasive mussels have dominated that level of their community, so they're outcompeting even, so the quagga mussels, for example, those are outcompeting even the other type of invasive species, which was, what do you remember? Zebra mussels. So the zebra mussels are currently being outcompeted by quagga mussels. So it really comes down to how many are highly abundant, how many are rare, and how many are moderately abundant. Again, we're going to see most are moderate. So just to give an example with those pictures, in A, we see that there are the same number of species. In between A and B, there's the same number of distinct tree types. However, in number B, there is not the same abundance, so we call that different evenness. So if a species is evenly distributed, there's exact same percentage of the same species, or there's an exact same percentage of all the species that are present and equally accounted for, then that would be a very even community. That is rarely what happens. There's usually one that dominates a landscape, and then again, more that are moderate, and then a few rare ones. So to give a on-topic example, we're going to look at A and B and compare, right? So for both of these, we have the exact same type of richness. We have 3 different species. We have, does anybody recognize all of these species? We were introduced to them last time. Any ideas? Red ear slider, yeah. What's the other one? Second one. Snapping turtle. And then there's one other one that looks just like the red ear slider but is in fact a native species. Painted turtle. Awesome. Good job, guys. So we have 3 species represented here. In A, the red-eared slider is significantly more abundant than either the painted turtle or the snapping turtle. So let's say this represents an eastern ecosystem, which means that the snapping turtle will be native and the painted turtle will be native. So that red ear slider is coming in and dominating, as a lot of aquatic invasive species do, and it's creating a really high level of unevenness. So when we think about species diversity, it's the variety of species in a community, and that includes both richness and abundance. So we're taking into account both how many species there are, how many distinct species there are, and then how evenly those species are distributed. So which would be the more diverse community? Good job. Yeah. So the implication is when we have a high percentage of aquatic invasive species that have established a population, would that increase or decrease diversity? It would decrease it. Yeah. So if we want to keep our communities nice and diverse, which is a really good quality to have in ecosystems, the best way that we can do that is to try to prevent these aquatic invasive species or any invasive species. Sorry, I am an aquatic invasive species person, so my mind always says aquatic, but there are terrestrial invasive species, and the plant people would be very upset with me for not saying that right off the bat. So one of the ways that we talk about environmental complexity is going to be in how it affects diversity. So if we have an environment, there can be multiple ways that we think about an environment. There's what is visible and then what isn't visible to the naked eye. So if we look at these two pictures down here, we see one side, which is pretty much what Flathead Lake looks like. I was just at Flathead today. I did some snorkeling. And that's what I saw, is that picture on the far right, if I'm facing you. This is kind of a terrain that is very minimal. There's open water, it's cold water, and then the substrate is all rocky. There's not a lot of open substrate, there's not a lot of vegetation. So we might not be seeing the same amount of crayfish, of young fish that are out in the open, because again, a lot of these crayfish and vulnerable species are going to be wanting that vegetative cover. So this one on the left is a lot more welcoming to like a nursery habitat or a crayfish habitat, because there's multiple levels of vegetation, right? There's that ground coverage. There's the tall plants that are even going on top and crusting that surface. And then there's kind of intermediate plants. And this is a lot less clear, right? The water is a little more obscured. So this is a lot more of a complex environment. This is a little more simple, but that's only what we can visibly see. The pH, the temperature, all these different factors that we consider when we're looking at environments, those can all affect the complexity. So even though this one might look more complex, there might be some surprises on that Flathead Lake type of environment. This is kind of what I was looking at Lake Mary Ronan this morning, where I was collecting samples, which I will show you guys later. But one of the things that we can find with these types of lakes on the far left or on the far right, if it's your side, I really haven't gotten down the sides. So I'm just going to say the far away one. That can create smaller environments if for some reason a tide got cut off. So when I was hiking today, I saw an area that had a lot of water accumulated, a lot of branches and logs that had brought in by the tide, and it was separated by the sandbar. That little spot was really, really rich in snails because it was a nice sheltered environment. It was warmer, it was shallower, and it had a lot of coverage. And so even if you have a Flathead Lake type of situation, there's all these different micro environments, all these different micro communities that can spring up. So just because the main part of the environment, the largest part, looks a certain way, that doesn't mean that there aren't micro environments, micro communities that can spring up. When you do have a complex environment, it allows for more niches, right? So there's more opportunities for different types of species to thrive in combination, rather than when you have more like, one or two niches that need to be filled because there simply isn't enough room. So when something like an invasive mussel comes in and strips all of the, all that bottom layer, right, that primary consumer level that we talked about earlier, when they affect that level and when they clear all of the water out, they're decreasing the environmental complexity of that lake. So fewer niches and less diversity. So one of the ways that we look at how a community is functioning is what the equilibrium is like. So equilibrium, which you've likely heard used in just daily life, but for ecology, it still implies that state of balance. Usually there's no species that are out competing the other. Everybody's kind of just in a standstill. Everything is in their niche, everything's functioning, everything's good. This rarely is what actually happens. Most environments and communities operate in a sequence of flux. So they have that equilibrium point and then they go up and down. And that's usually caused by, let's say, predator-prey relationships. So let's say we have a really good year for plant growth. We got a lot of rain, we got a lot of nutrients, the plants are going crazy. Those rabbits are gonna love that, right? So they are gonna have a huge population boom. They are gonna outnumber, let's say, the coyotes that would eat them. And so those coyotes are gonna have a really good year for eating, but they're still gonna be that out of balance, right? So they're gonna start eating, they're gonna start reproducing more to meet that demand, and then that will go up. Because as the coyote population goes up, the bunny rabbit population goes down. And so eventually it'll just keep going around that equilibrium state. One thing that will affect that equilibrium is disturbance. And disturbance can be anything. Disturbance can be more plants. Disturbance can be a larger coyote population. Disturbance can be, the example that my ecology professor used was the Serengeti. So when large herds of ungulates, so those, what do they have? Not deer, not elk. I've been in, yes, thank you, gazelles, things that are not native to Montana. When those come in those huge groups that travel across the Serengeti to migrate, they come in and they basically overturn that dirt. They mow down a lot of the different vegetation, and that allows this kind of recycling or restarting of this process. So when this has led to the theory or hypothesis that an intermediate level of disturbance is really good for communities and ecosystems because it prevents the strongest competitor from taking over, and it also prevents the quickest colonizer from taking over. So let's say a plant is really good at getting there first and growing really fast. If we had a lot of frequent, constant disturbance, that would be the predominant growth in a community. If we had really infrequent disturbance, we would have whatever is best at competing. So like those mussels, to go back and harp on them again, that's a good example of a species that hasn't had a disturbance that affects them. So they have become the dominant species in that ecosystem. So again, that intermediate disturbance hypothesis takes into account frequency and intensity of disturbance. Unfortunately, human disturbance is often high intensity and high frequency. And this directly reduces diversity. And it's for those two reasons, right? It encourages the fastest colonizer. So oftentimes that is something that can reproduce quickly. It takes a very short time to become sexually mature. And that's two of the qualities that we talked about with invasive species. So again, we see a decrease in that diversity. However, I do want to say that's not the case for all species. We have coyotes, we have raccoons, and those are two animals that thrive in a human environment. They've adapted alongside us, and they're commonly viewed as pests because of their proximity to us and because they thrive in proximity to us. To some degree, that also applies to the black bears that are in this area who have learned how to use our fruit trees and our garbage that is not properly secured. All of these things that they're able to create or able to thrive with that disturbance that we're causing. However, there are a lot of things that aren't able to do that. Does anybody have any examples of like a species that is specifically not thriving due to the frequency of human disturbance? Any ideas? Old growth trees, yep. So our forests look really different than what they traditionally would, just because of how many new tree species that are coming in because they grow fast and they don't have to worry about being taken out and having to regrow that really long time. Anything else? I would like to give the example of birds and how they really have trouble adjusting to our urban environments, at least a lot of the more sensitive species. So when we look at different species that we've kind of pressed out, that includes sensitive species like owls, birds that rely on a lot of insects, which we, you know, as humans try to avoid having near us, as evidenced by the recent fogging that's been going on. Not to put forward an official opinion on that, just an observation. So when we constantly mow, when we constantly apply herbicide, we're drastically reducing that disturbance, that intermediary between disturbance. And so it doesn't give much of an opportunity for more sensitive species to actually thrive or even reestablish. Okay, so now that we've gotten the general ecology out of the way, let's start in on freshwater ecology. So basic, what is freshwater? So freshwater is anything that is less than 1% salt. We have salt water, which is then more than 3% salt. And then we have brackish water, which is somewhere in the middle. Most of the water on Earth is salt water. You probably have heard that before. What we think of traditionally as freshwater, what kind of comes to mind when you think of freshwater? Like lakes and rivers and ponds. And so that makes up a very, very tiny percent of what freshwater actually is. So about 0.02% of all of our freshwater is surface water. 2.4% is frozen, and then 0.05% is underground. And that's our freshwater. Everything else is salt. And then, of course, we have brackish water, which I handily pointed out with that red circle. That occurs wherever salt and freshwater meet. So brackish water is that it kind of happens right at that salt front. And then freshwater will extend over like a cliff over salt water, and it'll have a mixing effect when the salt water is affected by tides. So it's a very interesting subject to study if you ever get the chance. We won't be going into it now because that would be, freshwater ecology is literally a college course that is a semester long. So we will be going over water habitats though. So this is a illustration taken out of this book. This is called Fish Watching. It is by just a lovely fish nerd who I just adore. It's a wonderful book for reading in depth into both habitats and behavior of fish in those habitats. I thought it was kind of just a joke because, you know, it's basically birding but for fish, and I didn't think that was a thing, but he takes it quite seriously. This is teaching you how to watch fish with binoculars and other things, but he does like binoculars. So to begin with, we have headwater streams. So this illustration is a watershed, and we will get into watersheds in the next slide or the slide after that. But just for now, a watershed is that entire area of a water system. So we begin with headwaters, which would be small streams that are usually arise from springs or wetlands. They're usually up the highest, and it's where we have the purest water, I think is what we conventionally think of it as. And then that flows into rocky creeks. And rocky creeks are really straight. They are heavily angled. So think about those really high alpine streams that you see that are just straight course, highly angled, flowing down. These tend to have pretty limited community or environmental diversity. Not a lot of vegetation, not a lot of stuff that provides a lot of different habitat, but there are some cool things that live up there. We then go into marshy creeks, and they're somewhat more diverse. They tend to have a lot more detritus. Thank you so much. I promise I am a professional. So they have a lot more detritus, and they tend to have muddy bottoms as well. So detritus is when we have that organic matter that sinks to the bottom, creates a really cool environment for decomposers like worms and crayfish, anything that likes that type of organic material. And then we have mid-reach streams, and those have conspicuous pools or riffles, and that's a section of stream where the current is deflected. So it kind of flows over the rocks. You might see this in some of our streams around here, where it kind of looks like a ladder is going down. And then that has a lot of diverse habitat. So when you have a midstream or a mid-reach stream, you have pools that can create some snail habitat, like I was talking about earlier, even though it was Flathead Lake that I gave an example of. If you do go out, I was just at one of the fishing access sites and Kelly's Island, and there were a ton of these types of pools and different areas that had branched off of the Clark Fork, and it was just a really cool way to see all the different habitats, lots of mosquito habitat, so that was cool. Just remember your bug spray. Base level streams are going to be a lot more sluggish, a lot more meandering, so they're going to have a lot more twists and turns. And then they turn into large rivers. And that is usually between base level and large rivers is where we see a lot of that sediment buildup and deposit. Large rivers are going to be navigable by industry. So these are ones that we use a lot for transport, both of people and for goods, materials, that type of thing. The Mississippi, the Missouri, the Ohio, those are all our large rivers. And then the large rivers will drain into somewhere, which is usually going to be something like an ocean or a sea. And right there is where we have that brackish water. Cool. Standing water habitats now. So we have wetlands, which let me see what his name is because that's tragedy. As Smith says, wetlands are tragically underrated. They have an incredible amount of diversity in them. They offer a really cool place for a lot of different species to have nursery areas, to raise young. There's a lot of different types of cover for vegetation, and there's always water. It's very, very infrequently open water, so it's not somewhere where we could recreate. But there are different types of wetlands. So we have a fen, which is fed by groundwater. We have a bog, which is fed by runoff. And then we have a swamp, which is wooded. The difference when you're in one, not going to make much of a difference to you. You're just going to be wet and soggy. Then we have ponds and small lakes, which are permanent standing water that have no wave action. That's what distinguishes it from large lakes. So if you go from one of our little community lakes to Flathead, you're going to notice that Flathead has actual wave action and shorelines that are wave swept, and you can see all of that kind of where the waves have left a lot of deposits, which is a great way to do community science, like we talked about last time. You and your kids can go or whatever children you have that you can borrow, can go and walk up and down and just see what you find in those tide areas. And it's one of my favorite pastimes. I've found a lot of invasive species that way, as well as a lot of cool native species. So we also have on this illustration the type of zones that we find in ponds and lakes. We have the littoral zone, which is the area that is closer to shore. And then we have the limnetic zone, which is open water. In the littoral zone, we usually see a lot of vegetation. We see a lot of animals that enjoy that vegetation. In the limnetic zone, we tend to see more of those open water fish. So when fishermen are looking for trout and that type of thing, they're going to head towards open water. If you're looking for crayfish, you are going to be in the littoral zone, like I was today. And then we also have different depths. So when you get to a certain point on the thermocline, which is that temperature variation, so when it gets suddenly very cold when you go deeper, that's the thermocline. And so that also impacts what type of animals and plants can live there. And also light visibility. So how deep does light penetrate? So this is just a throwback to what we talked about last time. So we have that primary producers that feed on energy that the sun provides. They then produce for the primary consumers to eat them. Secondary consumers then eat primary consumers, and tertiary consumers eat secondary consumers. This kind of gives the thing that I really want you to take away from this is how everything is built from the bottom up. And so a lot of times we're exploring the world around us from the top down. We focus on the fish that are like the rainbow trout or the coyotes and the cool mammals that eat all the tiny things that we don't think about. But without the tiny things that we don't think about, we wouldn't have anything else. So when we have something that affects these primary consumers or primary producers, we see that effect throughout the community. We had an example where a type of shrimp was introduced to feed some of the salmon, and this was earlier in the 1900s, not sure quite when. But basically they introduced a shrimp because they're like, this is going to help the salmon. And then it destroyed the salmon because they ate too many of the primary consumers, and then it was just a disaster. So that's just goes to show that sometimes scientists mess up and they don't consider what might be the interactions in a community. And so when we do community ecology, that's a really critical level of examination. Because again, we look at this type of balance, it's a delicate balance. And when it goes out of balance, that's a disturbance, right? And that can really, it could potentially destroy a whole community. So not to be too dismal there. Okay, watersheds. So a watershed is going to be an area that channels rainfall and snowmelt into creeks, streams, rivers, and then eventually to outflow points. And those outflow points can be the ocean, but it can also be reservoirs and bays and big lakes. So we have, I really do struggle to say this word because I've actually never heard it said out loud. So we're going to pretend that whatever way I say it is the correct way. So exoric basins are going to be a basin that drains into a river or ocean, so it goes out. That's that exo portion, right? Endoric, let's say that's true. Endo is within, right? So a basin that retains water, it doesn't allow that outflow. And so instead it goes into maybe a permanent lake or a dry lake or an underground accumulation of water. Can anybody think of a good example of that?
Would that be like a Great Lake?
So the Great Basin. So that extends through Oregon, California, Nevada, and Utah, and then a little bit into Idaho. But that is the largest example that we have here in the US, versus the Mississippi River Basin, which is that lower picture. And that's a huge basin that drains the largest area of river into the Gulf of Mexico. So, let me see if it does anything. There we go. Okay, so this is kind of just an illustration of the different areas. So we have the endorheic basins are represented in the green, and those are where everything is retained. So as you can see in the Sahara, where I'm from, is a very large basin. We also have that Great Basin represented there, and then we have a different type of basin that's over in our area. Does anybody know what basin we're in here in western Montana? Columbia River. So we are in the Columbia River Basin. So the Columbia River Basin is the only basin in the in actually North America that has not yet been infected with mussels, invasive mussels. So that's part of the reason why Montana has such a robust prevention and early detection program, is because keeping those out is really cool. And we've done a really good job for 30 plus years, and we intend to keep it that way. So this is the Columbia River Basin, just illustrated. This includes, oops, sorry, that was not what I intended to do. So the Columbia is the 7th longest river, but 4th in terms of output, so volume output. And it is the largest output of water into the Pacific Ocean. So it extends over 4 mountain ranges as well. So this is a really large basin. Not quite as large as the Great Basin, but it is still a really important basin, and it is the one that we're in, so it's even more important than the Great Basin. This is a zoom in. Part of this is the Columbia River Basin, part of it is not. That is that Continental Divide, right? We have Continental Divide in Montana, which does a lot to our ecosystems. We have basically that divide in the west. We have different ecosystems in the west than we do in the east. We have different native species to the west than we do in the east. And that, therefore, we have different invasives. But some of the big points that I'd like to point out is the Flathead Lake. We have Fort Peck. We have Canyon Ferry. So those are the big water bodies. We also have some really cool rivers. So we have the Kootenai River, Flathead River, Bitterroot, which we're all familiar with, I assume. But I just thought that it was cool to find that illustration just showing Montana through its waterways, because I don't think we often see a state through its waterways. I think, at least for me, I see it with highways and wherever the city is. And I just think it would be really cool if for once we're like, oh yeah, it's by Missouri River, instead of like, oh yeah, it's by Great Falls. Okay, so the fantastic fish of Montana. We have 91 different species of fish in Montana. 57 of those are native, and 34 species are either introduced or invasive. These are the lists. We're going to be going through all of those families. But just to kind of give you a look at the fish family tree there, which again, from fish watching. So we have over there, we have lampreys as the earliest, and then we go into sturgeons and paddlefish and gars. You're going to see this as we kind of get introduced to the families, but those are the oldest of the fish species. They've changed very little over the course of the millions of years that they've been around. They're really cool fish. They're my favorite fish. And then we kind of evolve more into the freshwater eels, the bowfins, which are very similar to, what do they resemble? Bowfins? We're going to find out together. Sturgeons, yeah. I love sturgeons, and gars are great. Gars have a cult following in the fish community. If you're ever on any form of social media, check out Solomon David. He's the gar guy. Literally has a PhD in gars. He did a collaboration with Oklahoma's Division of Fish and Wildlife recently, and I'm hoping that he'll do the same for us because it was very cool to see people engaging with gars. And you'll see why. They're very cool.
Are they only freshwater fish, or are there saltwater gars?
It's a really good question. This is freshwater ecology, I'll tell you that.
I always thought they were saltwater.
You know, I'm not sure. That is a really good question, though. So I'm going to look that up at some point. All the ones that I'm familiar with are freshwater, and so I can't think of a saltwater version, but they probably go into brackish. They're pretty adaptable. Okay.
They're freshwater, but several have a high tolerance for saltwater, several of the species.
Cool. Thank you. I appreciate that. Yeah, gar are really cool fish, and they are really tolerant and adaptable fish to stuff like that, not to other stuff such as human disturbance. Fish anatomy. So just take a good look at that fish. Knowing fish anatomy is going to be really helpful for compare and contrasting fish, and then also for fish identification. A lot of different, I would say all of the different families, because that's in part how they're classed, have physical differences. A lot of them have to do with how their fins are. So sometimes they're soft, sometimes they are spiny. So spiny, just like you would think of it, it's harder, it's not as malleable. It doesn't flop over when they come out of the water. And then we would have see that in the dorsal fins, the pelvic fins as well, and the anal fin. Those can all be soft or spiny, as well as the tail fin or the caudal fin. Another really good thing to look at is the mouth. So what type of adaptations do you think we'd see with mouths? Like if you saw a mouth or a fish with a really upturned mouth, what do you think that fish would be eating?
Like bugs.
Yeah. Why?
It'd probably be easier to eat them like off the surface of the water.
Exactly. Yeah. So when you see suckerfish, for example, they have their mouths really located on the bottom, and that's because they like to graze on algae and suck on things that are on the bottom. But when you have fish that have a really distinct upward mouth or a protruding mouth, they tend to be looking for things that are on the surface. We also have that contrast in color. So with few exceptions, fish tend to be dark on the top and light on the bottom. Any ideas why that would be? It's because if you're looking at them from the bottom of the lake or river, it's going to look like the sky. If you're looking down on them, it's going to look like the water. So that's also a really cool adaptation. I think fish are really cool to look at in terms of adaptations because it tends to be really physical. And I think sometimes we don't notice it as much in mammals because, mammals can vary so much in their physical presentation versus fish kind of have the same thing going on, with the fish body and the fins. So I think it's just a cool example. And look out for all the different adaptations that you can kind of guess at when we go through these families. So to begin with my favorite, we have the sturgeon family. We have 3 species in Montana. We have the white, the pallid, and the shovel-nosed sturgeon. The shovel-nosed sturgeon, so back up. So the white sturgeon is a species of concern. The pallid sturgeon is endangered. And then the shovel-nosed sturgeon is considered threatened. It's not actually threatened, but it looks enough like the other two that it's considered threatened by association because we don't want them to be caught. We don't want to open up fishing for shovel-nosed sturgeon and then have a bycatch. So pallid sturgeon are pictured right there. They have that really cool elongated nose. They kind of look like dinosaurs. And that's because they kind of are. They are they're a species that has changed very little over time. And instead of scales, they have those plates, interlocking plates, and they'll overlap. And as you can see, they have that spine on the back, which is very pronounced plates. So that's one way that you can ID them. They also tend to have that asymmetrical fin, that caudal fin. And then they only have one dorsal fin. They also will have those little barbels, so those little whiskers. Usually they have 4. Sometimes that can vary. Their nose will also vary based on species. Pallid has a much more elongated than shovel nose. Shovel nose, like it implies, is a little more shovel-shaped. And these are a family that has a very late maturity and a very long lifetime. So back to what we were talking about last time, things that tend to have reach sexual maturation later in life tend to have longer lives. This is a problem for this species because it has trouble keeping up in terms of disturbance. So species that reproduce very quickly and mature very quickly tend to do well with human disturbance, right? Because they colonize quickly. Species like the sturgeon, they don't do well with multiple high frequency disturbance that we are so prone to doing. In particular, they tend to struggle with dams and river blockages, river blockages and diversions. So FWP does monitor pallid sturgeons, and we do various like remote GPS work. One of the things that we'll do is have a little check station so that whenever a tagged sturgeon goes through, it registers, and we'll know how many sturgeon are successfully passing through areas that we've tried to divert or create ladders. One of the ladders that we have at Thompson Falls is specifically for bull trout. If you get a chance to go down to Thompson Falls and take a look at it, it's really cool to look at and you can see it. Other things other than bull trout do pass through, which is not great, but we'll take it, right? So, and what do you think their adaptation is in terms of their mouth placement?
It must be off the bottom.
Yep, got it. Yep, so they have that really lower mouth, and that's for lower feeding. They actually tend to exist in open water. So they are definitely open water fish, and they get quite large. They can grow to, they can continue to grow to about 100 years is their lifespan. And then they sexually mature at 10 years. So again, it's that late sexual maturation.
Do they have predators?
Us.
Besides us?
Depends what stage. So if they're small, yes.
Probably when the spines on the back will develop, they're safer.
When they're big and when they're mature, they're pretty hefty, and they are pretty well protected. So there's not a lot that really can access them in open water, and with them being as large as they are. So yeah, not very many predators other than humans, which we are a problem, as usual. So this is the sucker family. We have 9 species of suckerfish in Montana. Y'all can read, so I won't list all of them. They often have an undeserved reputation as a trash fish because people just don't kind of think that they're worthwhile. They're not really a game fish or a sports fish, but they are really cool fish, and I think they're quite pretty. And again, they have that really cool mouth adaptation. And even their lips are thickened so that they can more effectively suck things off of the bottom, so that detritus, algae, anything that they're able to get. And they are toothless. So that mouth is perfectly adapted for what they're aiming to do. And they are soft rayed, so they have no spines. Their fins are not stiff. And that's one of the ways that you can identify a sucker, although the mouth is the biggest clue. You shouldn't need to get to the fin stage. Oh, actually, one other thing that I wanted to say is that they are a good indicator species because they like to live in clean and unpolluted water, often near trout. And so an indicator species, I don't know if I defined it in our last program, but an indicator species is something that, as it sounds like, it indicates something. So oftentimes it'll indicate a certain condition. So if we have a lot of freshwater mussels, native freshwater mussels, that means that the river or lake is probably really clean because they're the first ones that feel the effects of pollution and they're the first ones that will disappear from an area that's heavily polluted. Okay, Sunfish Family. Remarkably pretty family. They are really stunning. We have 8 species in Montana. Almost none of them are native. They are introduced, not quite invasive, but we do keep an eye on them. They are commonly found in lakes and pools, which makes them a very popular sports fish. It's often the first fish that a lot of people will have caught is a member of the sunfish family, so they'll think very fondly of them. Bluegill especially. They have those 2 dorsal fins, so that first section and then the second section, and like our little fish anatomy fish example, these have spiny rays in the front and soft rays in the back. But again, that color and that deep body is really distinct for the sunfish family. Then we have the snakehead family. We have one species which is not found in Montana, but we are on the lookout for, and that is because they are super invasive. I kind of always think of this as the fish equivalent of a bullfrog, in that anything that it can fit in its mouth, it is going to eat. And it is capable of overland travel because it has air-breathing lungs. So that makes it so that they can survive in really oxygen-poor conditions. So small little puddles, they could live in that, which means they can eat a lot of mammals, a lot of waterfowl that are small enough, ducklings. So these are a problem. They are really cool looking, and they also resemble one of our native species, which I'll have you look out for and see if you can spot the similarities. But yeah, so this is the northern snakehead here. Yeah.
How does it manage the overland travel part?
It wriggles like an eel.
Really?
Yeah. Yeah. You can find YouTube videos that are well worth watching of just northern snakeheads going about their business. Again, they're very cool. They have great adaptations that make them such a successful competitor, but they are invasive because of their successful adaptations.
So is there a length of time that they can stay out of the water?
There is. I don't happen to know it, but it's not long. As with any fish, they're going to dry out faster. So they really try to keep to those really wet environments. Probably in wetlands, they would switch from pool to pool, but they wouldn't be going across a dam like some crayfish could manage. Across the road. That would be a very interesting thing to come across. That would be my end of my career. I'm out. So this is another really cool fish family. This is the sculpin family. We have 6 species in Montana. Don't know why I have the N there. That shouldn't be there, but some are native. Actually, I think all of these are native. They're small and bottom dwelling. And that's actually because, well, you can kind of see the adaptations that they have in their body, right? So a lot of their body is really dark, which makes sense, right? They're on the bottom. They want most of their body to blend in. And then they have a really flat bottom. So they're usually found crawling along the bottom with those big pelvic fins. And then that really low jaw. So kind of like the suckerfish. But again, with that suckerfish, you don't see those types of fins on them. Super cool fish. If you ever see one, really take a moment to look at them. They're hard to see because a lot of the time they are kind of in rocks and hiding away from either the currents or predators or whatever else. Carp. Carp are a problem. I am once again put the goldfish because I feel like I can't put that in enough places. That is a 67-pound goldfish found in France. We don't want carp in our waters. We do have common carp in our water or in our waterways. They are not as destructive as some of the Asian carp species like black carp, silver carp, big-headed carp. Those we will talk about, but they are a big problem in that they eat a lot. The way that their digestive system is set up, which again, I'm going to talk about this more when I have the carp up, the Asian carp up here. But they have a very unique digestive system that means that they eat almost constantly. So they eat a lot of vegetation, which takes away from habitat, food, breeding grounds, all of those things that other organisms in a community need to survive. And that will lower the diversity levels. They are toothless mouthed. They usually have soft rayed fins. They're pretty distinct. That face that you can kind of see in that goldfish. A lot of us are familiar with goldfish. They look very goldfishy. That face is very distinct. They're widespread in the eastern part of the state. They achieve their largest numbers in lakes and reservoirs. We're trying to keep them limited in the west. We do have one pond that is goldfish infested that I think we're going to try to work on. I wish I could remember the details of that, but yeah, it's going to be on a goldfish spree.
Where are they native?
So
if they're the largest and most ecologically diverse family, they've got to be native somewhere.
yeah, so they are native in a lot of different places. I believe that goldfish originate in Eurasia. I wish I knew the answer to that. But yeah, I mean, they are native to a lot of different places.
What species of carp are there? I mean, not just in Montana, but, you know, lots.
Lots. I'm trying to remember if they're the one that was like thousands,
Oh, wow.
or if that was a different family, but
It would make sense.
there's a lot. Yeah. Well, if they're the largest, then it is. It's thousands of carp species. Yeah. So yeah, it's a very large family. It's very diverse. It's not all just like goldfish and carp, that type of thing, but they are usually the problem invasive species or invasive fish, which I will talk about. But yeah, so that map is kind of showing where they are in Montana. Okay, we have the Kalifish family, which are darling, I personally think. They are introduced, and I saw one of them while snorkeling this morning. So they have that upturned mouth, which means that they probably eat things that are on the surface, which they do. They like to eat bugs. They are known for surviving in extreme areas, especially isolated springs. So they're well adapted to living in unconventional places, which makes them a good competitor. Thankfully, they have not become invasive, which is what we like to see. And then they have that really distinct rounding to their fins, and then those vertical stripes. You don't see vertical stripes very often. We have the pike family. So we have two species of pike, northern pike and then the tiger muskellunge. Let's say that I said that right. Both species are large and voracious predators. Northern pike is the most widely distributed cool water fish, and it's found in North America, Europe, and Asia. Northern pike are native to a very tiny percentage of Montana. It's that little tiny purple bit up there. The rest they are introduced, which is a problem. They tend to be, as I said, voracious predators. They can outcompete our native fish pretty easily. It's not to the point where we're listing them as an invasive species, but keep that in mind. And then they prefer weedy or vegetative habitats. People catch a lot of pike. If you go fishing in western Montana, there's a good chance that you're going to catch a pike. If you go fishing at Fort Peck, most people are there to catch pike because they get enormous in Fort Peck. And because they're such a popular sports fish, we continue to stock them. Or people continue to stock them themselves, which is not encouraged. We call that bucket biology, when somebody decides that they should get a bucket and put their favorite fish in their local pond or river or lake. Do not do that. That creates a lot of problems.
Do you think they wouldn't survive in a lot of bodies of water if they weren't restocked?
Pike would probably survive.
Oh, they would survive.
Yeah. Yeah, pike are pretty hardy. There's other species, one of which we'll mention today, that do need to be continually stocked. I'm not sure if we currently stock pike, because I do think that they've become pretty established. And people are starting to complain, such as to AmeriCorps who are manning a table and don't know anything about pike and don't stock pike personally, and really shouldn't be the person that they're lodging a complaint with. But they are starting to complain that all they catch is pike. So that's why we rely on their fishing skills. And when people catch pike, it's usually, we ask that they don't release them. So if you're doing catch and release, don't do that with pike. You can eat them. You can leave them on the shore. That's not great for our wildlife because that attracts them into human areas like bears. But we do ask that they not be re-released. Okay, Codfish family. Let's take a good look at that and see if that reminds you of anything. Pretty similar, right? So that's the burbot. Another one of my favorite fish, just because it has that scientific name, lotta, which I think is delightful. They are really easily recognized by that single chin barbell. So to go back, no chin barbell. Granted, something could have happened to remove that barbell, but there are enough differences up close seeing them, but usually you can just rely on that. If you're concerned, please take a picture, send it to us. Even if you think that it's probably just a burbot, we would love to see it, and we would also love to know if there is a northern snakehead. So no downsides. Either we get to see a burbot photo or we know about an invasive population. They are native, and they're actually a species of potential concern. So we're keeping a close eye on their population size. And the cool thing about them is that they spawn during the winter under the ice, which is unusual for Montana fish. But it is a great adaptation because Montana is cold. And so if they can thrive and reproduce under ice, that's great for them and their population. They are largely nocturnal, and they are also voracious predators, just like snakeheads. But because they're native, they don't throw that community out of equilibrium. We have the Stickleback family. Why do you think they're called Stickleback? So these are super unique looking fish. That really helps for their ID. They are a species of potential concern, but they're also introduced in some places. You're going to see that with some of these fish. The Arctic grayling, for example, that's a trout species, I think, or salmonid species. They have that beautiful sail fin. If you've ever seen one, it's very distinct. But they are both a species of concern because they are decreasing, and also an introduced species that we're worried about being in different areas because we don't want them there. And that was bucket biology because Arctic grayling are a very popular sports fish, and people wanted to introduce them into some of the lakes here and some of the other areas that they are just not supposed to be in. So these are small fish. They're usually found in marine waters, but they can be found in fresh waters, just like this one is. And the freshwater group is thought to be freshwater rather than marine because it got trapped and isolated during the Ice Age. And then so it evolved different features that made it adapted to freshwater. So cool how that can happen. We have that divergence in the same group, the same family group, but we have one little freshwater species in it. The goby family. Bad. We don't want to see gobies in Montana. They are an aquatic invasive species. They kind of look like sturgeons, except gobies are, the best way I can describe it, as rounder and less crusty. Sculpins are always very pointy and kind of a little crusty. Not actually crusty, but just the vibes, you know. Gobies are very streamlined. We only have one goby that we're on the lookout for here in Montana. It's the round goby. And we haven't had any detections, although they are very hard to spot. They tend to really like to hide out under rocks. They're very good at hiding, and so they're really difficult to study, even where they're native. So we have usually 10 to 20 new species popping up every single year. So they might soon outmatch the carp in the most freshwater species. So I think they're up to 1,800 species so far, almost 1,900. So then we have the mooneye family. We only have the goldeye, which is a native to Montana. As you can see, it's native to the eastern portion. They have this really cool metallic gold or silver gleam to their eye, which is how they get their name. And then they have deep bodies. So when we say deep bodies, it goes down, kind of like a deep-bodied dog versus like a German Shepherd versus something that is a little less deep-bodied, like a Chihuahua, something. So we have that deep body, and then we have large silvery scales. They also tend to have really large eyes and then a forked tail. Interesting tidbit, there are only 2 living species in the mooneye family. The other 3 are extinct. They were extinct not due to human issues, which is always nice to hear, you know. Then we have the catfish family. So I usually hear from people that they think all the catfish in Montana are invasive or introduced, and they are not. The channel catfish and the stone cat are both native to Montana. And then we do have the introduced bullhead species. So black bullhead, you can see over there. The yellow bullhead looks very similar to the black bullhead, just slightly lighter in color, as you can probably guess. Catfish have that really distinct 4 pairs of barbels, and they have no scales. So they just kind of have skin. They don't have that sturgeon feature where they have that armor-like plates. Catfish just have skin. They are also toothless. And the bullheads rarely exceed 1 pound, so they're usually pretty small. So they're usually not a great game fish or a great sports fish because they also like to steal bait, and they're very good at it. The stone cats are also too small, and they can inflict a sting from their spines. So they have those spiny rayed fins. And yeah, they can sting. It's not harmful to people, it just hurts. This is a stone cat. I think they look really cool. They are a super valuable indicator species. They only live where the water quality is really good. They do not tolerate any type of heavy pollution or heavy silt. So if you see a stone cat that is alive and happy, it means we have good waters. Now we have the gar family. We have 1 species in Montana. It is the short-nosed gar, and it is a species of concern. That means we're watching its population to make sure that it doesn't decline any further. Gar are really cool, just like sturgeon. They are that really earlier type of species that hasn't diverged or evolved much since, we call it a primitive species, but I think that kind of gives the wrong vibe, you know? They're really cool. They just haven't needed to adapt because they're so cool. They've gotten everything that they needed to do out of the way right from the start, and now they're just look like dinosaurs. They also kind of look like pike. Once you kind of get a feel for pike and gar, they're very hard to confuse. Gar have that very long snout, and they're also air breathing when they need to be. So that allows them to survive in that really low oxygen conditions. If you see a log that is moving, could be a gar, because they often float in the water at the surface like logs. It does make them very vulnerable to human predation, especially bow hunting, spear hunting, which can really take a toll on their species or on their population, especially because, just like sturgeon, they have that late sexual maturation and a really, really long lifespan. They can also grow to like 10 feet. Not this species in particular, but the giant alligator gar, which is native to more of the eastern half of the US. They can get very, very large. But they are harmless even though they do have teeth. They are not going to be an issue for people. We are an issue for them. Minnow family. We have 21 species in Montana. I am not going to talk about all of them. I highly recommend downloading the Montana Fishes app off of the App Store. It will tell you a ton of cool things about every single fish that we have here in Montana. It was developed by our fisheries people, and it's like talking to a fisheries person. They will talk to you constantly about fish and all the little cool facts, so highly recommend. We have minnows that are both native, and we have introduced minnows as well. This is a cool little picture that I found from somebody who is very upset that some fish are considered or thought of as minnows when they aren't. So that includes some of the mosquito fishes, which are not minnows, cigar minnows, which are scads, but things like shiners, daces, big-headed carp are also minnows, which is interesting. We don't want those. Those are the invasive, but they are minnow family. Most of them are small, although that, as I just mentioned, big-headed carp, those get very big. So it's not exclusively small. They often school together, and then they feed on insects and algae, so usually vegetation. And they're usually a good prey source for sports fish, although the bigger minnows are also really good for sport as well. The largest Native American minnow is the Colorado pike minnow, which is a species of concern. And we currently have cool conservation efforts going on in, I think it was Utah that I was listening to. There's a podcast that's, what is it called? It's On Your List. And it's run by the U.S. Fish and Wildlife Service. And I think it's Fish of the Week. They just had somebody who works with pike minnow on, and it was a great talk. So if you get a chance, highly recommend. But pike minnow can grow to 100 pounds and 6 feet long. So what we conventionally think of as minnows, not always how they're actually represented in the family. Then we have the temperate bass family. We have one species of this family in Montana, and that is the white bass. It is introduced, but they are true bass. So when we think about largemouth and smallmouth bass, which we hear about probably a lot, it's a very popular sports fish, those are actually sunfish. So not bass at all. Most freshwater populations are sustained through stocking. So this is what I was talking about when we had that question earlier about pike. Temperate bass do need to be maintained through regular stocking. They usually spawn in tidal rivers, but they have adapted to landlocked areas, such as Montana. But again, they do probably need that extra help to keep up. And they do have teeth. Haven't been bit by one though. Then we have the smelt family. We have one species, which is the rainbow smelt, and it was introduced to us by North Dakota. Thank you, North Dakota. They're not an invasive species though, so no real concerns there. They're pretty small and they're slender, and they have that adipose fin. So it's that one back there. And then they're closely related to salmon and trout. Perch family. Some of the prettiest fish. We have 4 species in Montana. The Iowa darter is pictured. And then we have the sauger, which is that one over there. The sauger is a species of concern, as is the Iowa darter. And that is because not only of other human-caused issues, which are, human disturbances, but also because they tend to hybridize with those walleye and yellow perch. So that can be a problem. That we see this same issue with a lot of our trout species as well. They're hybridizing and they can't sustain their unique populations. They tend to rest on the bottom using their pelvic fins. So that's why they're called perch, is because they like to perch on the bottom. Then we have the trout perch family, which I think is a weird name choice, but who am I to argue with the people who put everything into families? They do something that I could never even hope to do. They are native to a very small portion of Montana, and they are a species of concern, which means that we do think that they are decreasing. They have 2 living species and 2 extinct species, both of which are native to North America. Then we have the live bearer family. All of them are introduced here in Montana. We have 5 of them, including the mosquito fish, which is commonly thought of as a minnow, but is not. The ones pictured are the sailfin mollies, which are really cool to look at. Oftentimes they become pets because of their appearance. And as their family name implies, they do give birth to live young. Their eggs hatch internally. So instead of laying eggs like most fish, the development is fully internal, and then the young emerge free swimming, which is also a cool adaptation. They are popular aquarium fish, as I've said before, so that leads a lot to illegal introductions through just dumping aquarium pets. Do not do that. Paddlefish, which are extremely cool. They are, as we saw on that very first slide that introduced you to fish, they are closely, they're close to gar and sturgeon. I think they're actually considered a type of sturgeon, if I remember correctly. But there's 6 known species, 2 are extinct, 4 are extinct, 2 are currently extant, which is the opposite of extinct. The American paddlefish and then the Chinese paddlefish. Dams are really altering their feeding and spawning, so they're really struggling with dams. That's decreasing their population size, and it's also leading to genetic isolation. Their meat and their eggs are also increasing in demand, and that led to a pretty sharp population decline earlier before they became protected. Paddlefish you can still fish for here in Montana, but we do limit the number of paddlefish that can be harvested. Just like the gar and the sturgeon, they're slow to mature and they're slow to reproduce. They have extremely small eyes. Their eyes are like right here. And then that really long snout is covered in electroreceptors. So that's why they don't need big eyes, is because their huge snout is really good at gathering environmental information and locating prey through really dark and turbid waters. So they're really cool adaptation right there. They have that forked asymmetrical tail, and they are scaleless except for a tiny patch near their skin or near their tail. They also don't have those plates like gar and sturgeon do. And they can grow up to 140 pounds. Then we have the trout family. So we have 16 species in Montana. They are some of the most well-known and popular species that we have in Montana. Some are introduced, some are native, some are both, such as the Arctic grayling, which is that one up there next to the, I think that's the West Slope cutthroat trout. And then down there we have a bull trout. So bull trout are one of our top species of concern. We're working really hard to conserve them, along with the West Slope and Yellowstone cutthroat trout. All three of those species are having trouble with hybridization. We also have the lake whitefish that is also native, the Columbia River redband trout, the pygmy whitefish, the mountain whitefish. Lake trout are native to the Southwest, not in all the other places that they are, but again, popular with bucket biologists. And the Arctic grayling is also native to certain parts. Most of them prefer cold water and open water. Then we have the drum family. They are called drums because they create a drumming sound with one of their, they have a special set of muscles around their swim bladder that vibrates that swim bladder and creates grunting. So that's really cool. Not really a sports fish. That grunting is only found in mature males, so it's assumed to be associated with sexual selection. When we see species that, only the male, or actually it's usually only the male has a certain trait, we try to look at it and see if it's sexual selection related, because if only the male has it, but the females are also surviving, and it's not just all the males asexually reproducing, then it can't be essential to survival, right? So it has to be something that is typically related to either sexual selection by appealing to the female, like with bright colors, or for fighting males, like bighorn sheep. They have those huge horns to fight off males for females. Then we have the mud minnow family. We have only one species here in central Montana. It's the central mud minnow in Montana. It also has body structures that allow for air breathing, and this allows them to survive in oxygen-poor water during the winter. It uses those tiny air bubbles that get trapped in underneath the ice, and that allows them to be active year-round. So that can make them a pretty popular sports fish, depending on what you're looking for. It's also related to pikes, and it is an ambush predator, even though it looks pretty harmless right there. Then we have the Asian carp. This is the last fish family that we're going to cover. And I do know that I'm running short on time, so thank you for hanging in there with me. We have 4 species that we're on the lookout for: grass carp, silver carp, bighead carp, and black carp. These are extremely problematic because of how much vegetation they manage to eat. They lack a true stomach, so they absorb nutrients through their intestines, and that is a very inefficient way of absorbing nutrients. So they have to eat a lot of food to compensate for that poor absorption. So they can eat up to 40% of their body weight each day, considering silver carp can reach up to 100 pounds. That's a problem. But they were actually introduced to America because of their ability to eat a lot of vegetation, because we were like, what would be a great way to manage all of our invasive aquatic plants? An invasive fish. Didn't think that one through. Now we have our freshwater mussels, which I talked about before. We have 3 species of native mussels here in Montana. These are the 3. We also have 3 species of introduced mussels that are not invasive, non-problematic. As I was saying, these are an excellent indicator species. They are really intolerant of pollution, which makes them, freshwater mussels in general, the most endangered group in America right now, because they have really suffered from pollution as well as being over-harvested, both for their shell, for buttons, and then for freshwater pearls. So the giant floater, the fat mucket, and the western pearl shell. Excellent naming. That one's bare, don't know why. This is the mussel life cycle. As you can see, they require a fish host. So the young, they have a broadcast spawning, which means that they send out their eggs and their sperm into the water to be intermixed. And then the little larva will grab onto a fish either through intake, and so they'll want to be eaten and they'll get attached to the gills, which is a cool way to do that. Some of the mussels actually will wave their little spout to kind of get the fish to come closer and investigate them. It's a foot, not a spout. They'll wave their foot to imitate like certain fish's prey, and then they can release their young into the fish directly. Just the Zoo of Us, a podcast that is also on your list, just did an episode on freshwater mussels, which I felt was very well timed, and it's a great episode. And it talks about this and how the certain mussels prefer certain species, such as the western pearl shell, which I talked about. They tend to prefer western cutthroat trout, which are declining. And so as a result, freshwater mussels are having a problem. Everyone here was here for my talk about invasive mussels, so I'm going to skip that. You know that they broadcast into the water and create free-floating larvae, which allows them to follow or flow through. They do not need a fish host. That means that they have that adaptation. These are some of the insects. We're going to skip over the insects for now. We'll cover those in bugs and botany. And then we have crayfish. We have virile crayfish, which are native to the east, introduced to the west. These are all I've been seeing in the west recently. I've really struggled to find signal crayfish, which are native to the west and introduced to the east. We have eastern plains crayfish, which are invasive. Those were found in Miles City hatchery, and they were successfully eradicated from that hatchery by our early detection team, specifically the crayfish team, which is an awesome team. They have some really cool Fisheries Friday videos up on our social media. And they went in and they, eastern plains crayfish burrow. And so they can be really destructive to bankside habitat because they'll burrow through and collapse everything and erode it even more than it already is. And so they were able to put really hot water into the burrows and basically cook them because, you know, like we do with lobsters. And when we went back the next morning to collect them and see, you know, if it was effective, all we found were little raccoon paw prints and some very, very happy raccoons. So thank you, shout out to raccoons for doing the cleanup. And then we have calico crayfish, which are native to the east, and we only found a very small population of these guys, but hopefully we'll find more. We really encourage people to go out and do crayfish studies. It's super easy to do. If you're interested, just talk to me. We can go crayfish surveying. And yeah, it's a great way, especially for kids and high school students, to get involved. Finally, we have freshwater snails. I am going to divide them into Physa, Limnaea, and Planorbid. Freshwater snails are notoriously difficult to ID. Usually what we rely on is the general shell shape. So Planorbid is the easiest. It has that circular, and then it's flat-sided. So kind of like a cinnamon roll. Physa is going to open up to the right. So that upper corner, that's a Physa. And then the Limnaea are going to open up to the left. And I have examples of the crayfish and the snails. So lecture portion is over. We get to go over to the table. Okay, so today I have for you one dead crayfish. He was like that when I found him. One alive crayfish who I found snorkeling. He is very tiny. As you can see, he has those little, oh, I know. Okay, we'll put you back. We'll show the dead one off, okay? So the dead one is much larger. It has those orange tips to its claws. So virile crayfish have orange tips and these usually bright blue. This one has kind of dull claws, but if you're going around the water, you can usually find these bright little blue spots. Those are detached claws that have been eaten by something, and they've just left the claws. There's also an areola, which is this covering to their carapace. And there's these little, it's kind of like two semicircles, and usually they come really, really close to touching, or they're actually touching in virile crayfish. In signal crayfish, it'll be much wider. Signal crayfish also have white spots right here, and their claws look different. And then rusty crayfish, which we talked about last time, which are invasive, they would have a really rusty spot right here, and their claws would be very, very large. So that's a mature I'm just going to keep this open. That's a mature full-grown one. This one is little, and so little that I cannot find him. There he is. Yes, we're very mad. Yes. So crayfish back up. They don't really go forward to hide. So you can see the underside. It can be hard to sex crayfish. This one is too teeny, but we can try with this one. So this one is male, and it has these little extra claspers on him, and that's used to hold the female during mating. So now we can move on to the snails. These are snails that I managed to collect at Flathead. They are much slower than the crayfish. So this, which one do you think that this one is? So it opens to the right. Yes. So FISA are going to be a lot less, they have less of a spiral, especially when we compare it to this. So this one opens to the left. What do we think that is? Perfect. Yeah, so this one has a very defined spiral. And we have to watch out for the ones that are opening to the left because we have mud snails, New Zealand mud snails, which are invasive. They open to the left. They're a type of limnaea, but they are much, much smaller than this guy. And so, let me see if I have the planorbid still. Probably not. It was in one of these, but I think it got disappeared. But these were found, so I found these just in one of the little pools that was left behind by that outgoing tide at Flathead, and it was just filled. And everybody was walking by these little pools without looking at them, even though we were all out there as FWP members. And we were working on trail improvement, and it's like, we had some free time, right? So we're exploring, we're seeing what we can find. It's like, man, we're not finding anything. And so I go to this pool, and I'm just like sitting there, and I'm looking, and suddenly I see all the snails. And that happens a lot with aquatic species, where you're looking at something and you can be looking at it for several minutes, and until you see the first one, they're almost invisible. And then once you see one, you find all of them. And so these guys were breeding, they're spawning eggs. Sometimes if you like flip over logs that they're on, you'll see little egg pouches, and they're just like a very clear booger. Scientific term there. And if you take a close look at these guys, you're welcome to with any of these after we're done. You can see some of them are emerging from their shell, so you can see parts of the inner snail, which is cool. But yeah, that's freshwater ecology and species. Sorry for skipping bugs. We will get to them. I promise to my bug people we will. But yeah, great job. Thank you for sitting through that with me. I know that was a long one, but hopefully you enjoyed it. So,
Thank you.
Yes,
cool.
Thank you.
This might be a dumb question.
No
but
such thing.
How do snails like get their shells. Like I
Yeah.
kind of always
So
thought
they-
of like hermit crabs where they just
Right?
like find the shell and like
Yes.
stick with it. But like, how do the shells get made?
So that's not a dumb question because
Okay.
that's a very good question because I had that question. So snails actually produce their shell. So it grows with them and they continue to eat things that have the right minerals and nutrients for them to continue to produce that
Kind
shell.
of like an exoskeleton.
Exactly. Yeah, except one that is better adapted for aquatic life and for what it is that they do. For our native species, they don't have this, but invasive species are able to kind of, I think it's called an operculum, and it's basically, it seals their shell shut, so it's like a trap door, and it lets them be outside of the water for longer periods of time, for like 5 days, I think is about what they can manage. So like New Zealand mud snails, they have that operculum and they can just shut the shell and just be fine and be in that aquatic environment inside their shell. And that's what helps them spread so much, is that adaptation that they have. These guys do not have that. If you look at them,
I've seen that.
they are very squishy, you know, that part of them is not hidden away, it's not hard. So they are very unprotected. So they really rely on that wet environment. So wetlands, little ponds, sometimes they'll be in bigger lakes, but they really like to find that little micro habitat, that little micro community that has a lot of vegetation for them to cling on to and for depositing their eggs, and to, of course, hide from predators, because these are perfectly snack sized for a lot of organisms. So yeah, good question. Any other questions?
How would you pick up the crayfish if it was alive?
Yes. So,
Gloves?
Yeah.
Grabber?
so one of the ways that I really like catching crayfish is snorkeling.
Okay.
And snorkeling, they don't run from you as much. They like to hide if they like hear you or see you coming in walking. But for whatever reason, when you're snorkeling and coming in from above them, they just kind of like stare up at you, which doesn't seem like a great adaptation, but it seemed to be working for them. So with this guy, I just lifted up a rock and saw him scuttling and just grabbed him with my hand. You can absolutely get one of those little short nets and just scoop them up. There's crayfish traps. I am testing out mine. I haven't caught anything yet, but it's because I'm impatient. Usually people will throw them in with some dead fish as bait, or some meat or something. Cat food works well too. Throw them in to somewhere that you think crayfish would be living. So these guys I found in kind of a reedy area of Lake Mary Ronan. Tons of crayfish in that lake. So not a ton in Flathead, tons there. But yeah, just toss it in and then wait for, you can leave it overnight, which is probably the best way to do it, because then they tend to be more active at night, and they'll be wanting that food. So yeah, crayfish traps, snorkeling, just walking along the water and, wading in and flipping rocks.
Have you been bitten by one?
Yes. The small ones are surprisingly wily. They'll attach themselves right to the skin of your finger.
I used to.
You blow on them, and that's how you get them to release.
I used to
just
hunt
blow
for crayfish as a kid, and I don't remember I know I must have gone.
Same for me. I don't remember ever catching them, but we always looked for them.
Oh, I remember catching them.
Because if you
we
pick
had
them
a
up
little
like
bucket
right
filled
behind
with
their little
pinchers.
right?
And
They shouldn't get you.
Yeah, so when I picked him up, if you pick him up right like that, and that's the thing. So
Fast.
they're fast and they back up, but they'll also back up right into your hand if you're like perfectly situated which I am not in this little tank. Yeah, so I hold him right here. His little claws can't get me.
Yeah.
Okay.
And when you're taking photos for identification, making sure to get the claws and the carapace, so that back part of it, so in there. Dead crayfish, also very valuable to science. We can see what species is there.
They don't have to be alive for us to do that. All we ask is that wherever you collect them, either re-release them back where that was. So I'm going to have to drive all the way to the lake to release this guy, which is fine. He has a family. We're going to go put him back with that family. And same with the snails. They're going right back where I found them. Or if you're keeping them, just make sure that that's fine with the fishing license or whatever you have it through. Send us a photo, or if you think it's suspect, you can even just deliver it to us. We'll never say no to a crayfish sample. So, yeah, but that's the way that I like to do it. One of the ways that I've also done it with having a net is I had one other person helping me, and they would walk towards it, and I would be behind it, and they'll just back right into the net. So that's really nice.
That's easy, yeah.
Yeah. The kids can be on crayfish scare duty, which is very popular. So, yeah. Any other questions? Cool.
Thank you.
Yeah, thank you.